So Algebra 1 test number 11 through lesson 4.2 where we graphing equations using tables and lists of data. First problem is the only multiple choice problem. Which one's an identity? Remember, an identity problem is going to be true when you plug in the values or when you simplify each side. We simplify A, 7W you can combine with negative 1W. You get 6W. Plus 4 is going to be left alone is equal to, when you distribute on the right, you still have 8W when you distribute. Negative 2 times W is minus 2W. Negative 2 times negative 2, and negative times a negative is a positive 4. When you combine 8W and negative 2W, you get 6W plus 4. Notice that's the exact same thing as what's on the left. A is going to be correct one. For B, negative 3V minus 4 will leave you with 10, because 14 minus 4 is 10, minus 3V equals negative 3V minus 10. You got negative 3B is the same on both sides, but notice negative versus positive 10. That's why B doesn't work. Negative 8Y plus 4 is equal to negative 8Y. Those are the same, but 4 is not the same as negative 7. That's why C doesn't work. And then when you combine 8M and negative M, you get 7M, which is the same as the 7M on the other side, but 8 is not the same as 6. That's why D doesn't work. A is the correct answer for 1. Graphing, we only learned one way so far to graph equations in here for the next handful of problems. Y is equal to negative X plus 2. We graph them using an input-output table or a chart of XY values. Negative 1, 0, and 1, remember your easiest ones. So when you plug in place of X, it's already negative. So it becomes negative 1 plus 2, which is positive 1 plus 2, which is 3. The next one, when you plug in 0, it doesn't matter what kind of negatives or positive you multiply by 0, you still get 0. That plus 2 is 2. And then for the last one, it's negative when you plug in 1. It becomes negative 1 plus 2, which is the same thing as 2 minus 1, which is going to be 1. So we have a set of 3 ordered pairs here. When we graph our equation, we're going to have to draw ourselves a coordinate plane. Negative 1, positive 1, 2, 3. That's the first point right there. Negative 1, positive 3. So at negative 1, positive 3 is your first point. The next one is going to be 0, 2. You don't go left or right at all for 0, but you go up 1, 2. There's your second point. And then the last one is 1, 1. You go to the right one time, and you go up one time. There's your third point. You have 3 points. You draw your line through your points to show your graph. Next one says y equals 4x plus 4. Again, x, y. You want to make a set of input-output values, negative 1, 0, and 1. Remember, the only time you want to use numbers besides these is with fractions. You want to use the number. You want to use the denominator is usually easier. But when we plug in place of x, negative 1, we get 4 times negative 1, which is negative 4 plus 4 is going to be 0 for the first one. When we plug in 0 right here, we know anything times 0 is 0. That plus 4 is 4. And then when we plug in the last one, 1 times 4 is going to be 4, and 4 plus 4 is going to be 8. So we have 3 sets of values right here. Negative 1, 0, 0, 4, and 1, 8. Not 3 sets of values, 3 ordered pairs. So we have to go again. We don't have to go left or right very far. We only have to go to the negative 1 value and the positive 1 value. But we have to get as high as the number 8 on our y-axis. So notice I drew it showing more of them going up. 3, 4, 5, 6, 7, 8. So the first one, negative 1, 0, is at negative 1, and you don't go up or down at all. The next one, 0, 4, you don't go left or right at all, but you go up 1, 2, 3, 4. And then the last one, 1, 8, you go to the right one time, and you go up on your y-axis 8 times. When you have all 3 points, again, you do a little better job than I just did. You connect through your lines to make your equation. Then you had a horizontal and a vertical line. Y is equal to 3. So on a coordinate plane again, your y-axis, don't forget, is the one that's going up and down. Remember, this looks like a capital Y if you do this. That's how you can tell. So where y's value is 1, 2, 3, it's going to cross through there. It's going to be 3 at this value, and it's going to be 3 at this value, and at every infinite number to the right and to the left, both positive and negative. So you're going to have a horizontal line like this. There's no reason to have a set of data to do that. The same thing with x is equal to negative 4. You're going to have yourself a coordinate plane. X's value, since this is your x-axis here, is negative 1, 2, 3, 4. That's where it's going to cross through. Where at this y value, it's going to be negative 4. At this y value, it's going to be negative 4. And infinitely, both up and down, it'll be crossing through at negative 4. So that is a horizontal line. Again, y is 3. X is equal to negative 4 is vertical. Number 6 says solve the equation for y, then graph the equation. So the first thing you want to do is you want to get it to say y equals all by itself. We don't quite have that for this first one. We have to move the 4x over to the other side by subtracting 4x. If you subtract it on the left, you have to subtract it on the right. Make it say mx plus b just to get used to it for next week. So make it say, so we have 3 minus 4x. Again, put your mx first. So negative 4x. And then positive 3. So now it says mx plus b. So the first part said to solve for y. We just did that. The second part says then graph the equation. Again, make yourself a set of values, x, y. The first one, 0. When we plug in 0 in place of x, we get negative 4 times 0, which is 0. And 0 plus 3 is 3. The next one, when we plug in, let's say negative 1. Negative 1 times negative 4, negative times a negative is going to be a positive 4, and 4 plus 3 is 7. And then the last one, when we plug in 1, negative 4 times 1 is negative 4 plus 3, which is negative 1. So we have 3 sets of ordered pairs. We can graph our equation. We have to go as far left and right as 1 and negative 1. We're going to have to go down at least 1, and we're going to have to go as far up as 7. 2, 3, 4, 5, 6, 7. So the first point, 0, 3. At 0, 1, 2, 3 is your first point. The next one, negative 1, 7. You're going to go to the left 1, and you're going to go up 7. And then the last one, 1, negative 1. You're going to go to the right 1, and you're going to go down 1 since it's negative 1. You have 3 points. Again, through your 3 points, you can draw yourself an equation. Number 7, we are again solving for y, and then we're graphing it. So in order to solve for y, you need to get y by itself. This is going to be a two-stepper, unlike the last one. Move negative 5x over by adding 5x. If you do it to the left, do it to the right. That doesn't give you 17x. Remember, they're not like terms. When you cancel these out, you are still left with negative 4 times y on the left. Putting 5x first and then positive 12 will make it say mx plus b quicker. Get rid of negative 4 times something by dividing by negative 4. If you do it to the left, do it to everything on the right, that one and this one. It'll cancel the left and leave you with y equals. That's what we were trying to get. A positive divided by negative 5 divided by 4, we can leave it just like that. Negative 5 over 4 times x. And then a positive 12 divided by a negative 4, positive divided by negative is a negative 3. This says y equals mx plus b. Okay? Again, we haven't learned slope-intercept form in here yet, so the only way we can do it is to make ourselves a table of values, x, comma, y. 0 is always easy to use because you can multiply anything by 0 and get 0. Numbers that are 4 are better to use than 1 and 2 right here. So let's use negative 4 and positive 4, and it's going to make our lives much easier right here. So the first one, 0 is the easiest one. When we plug in 0 right here, anything times 0 is 0. 0 minus 3 is negative 3. The next one we plug in this same spot right here, I'm pointing at that one, but plug it in place of x. Negative 4, I'm going to erase this in a second. Negative 4 times negative 5 over 4. Remember, that's the same thing as over 1. What this is going to do is cancel this out and then leave you with a negative 5 times a negative 1, which gives you a positive 5 for that one. So negative 4 goes through at positive 5. And when you plug it in one more time, but this time with a positive 4, you have negative 5 over 4 times 4 in place of x, or 4 over 1. Again, this cancels out, and it leaves you with negative 5 times 1, which is negative 5 over 1. So even though our numbers are slightly bigger than they would have been by using 4 and -4, we have integers. We don't have fractions that we have to deal with. So when we graph our table, we have to go as far to the left and right as positive and -4. So you want to draw yourself a relatively even plane right here. So go to the left, 1, 2, 3, 4. Go to the right, 1, 2, 3, 4. Go up as high as 1, 2, 3, 4, 5, and go down as far as 5. So your first point, 0, -3. You don't go left or right at all. You go down 1, 2, 3. Your next one, -4, +5. You go to the left 4 and you go up 1, 2, 3, 4, 5. And the last one, 4, -5. You go to the right 4 and you go down 1, 2, 3, 4, 5. I feel as if I made a mistake somewhere. Let me check it. Things are misaligned. Okay, I caught the mistake I made. The reason that they're not in, these points are actually in the correct position. I know it's not giving you a straight line. The reason they're not is because you can look at my tick marks on my graph. Some of them are smaller and closer to each other than the other ones. But if you were doing this on a sheet of graph paper, you would have come up with these points in this position, and it would be a perfectly straight line. Then we get into last week and all our past stuff. 3p minus 1 is equal to 5p minus 1 minus 2 times 7 minus 2p. Remember, when you're simplifying, you always simplify the left side, 3p minus 1. There's nothing you can put together there. And then you simplify the right side before you try to move anything across. So you have to distribute 5p to both of these. That gives you 5p minus 5. You have to distribute -2 to both of these. That gives you -14. Negative times a negative is going to be a positive 4p. Then you can combine 5p and 4p to get 9p. You can also combine -5 and -14 to get -19. Now you can't put those two together because they're not like terms. Now you're ready to bring the rest of it down, 3p minus 1, and then start moving stuff across the equal sign. Remember, move the smaller 3p over first by subtracting it since it says positive 3p. Do it here. 9p minus 3p is 6p minus 19 equals, there's still -1 on the left. Since you moved 6p to the right, move -19 to the left. It says negative or minus 19. Add 19 to both sides. If you do it there, do it here. -1 plus 19 is positive 18 is equal to 6p. And then in order to get p by itself, divide by 6. Do it to this side. 18 divided by 6. P's value is going to be equal to 3. Do the same thing with number 9. You have smaller x. 4x is smaller than 5x. Move it over by subtracting 4x. If you do it from the left, do it from the right. 5x minus 4x is 1x. You still have -9 on the right, and you still have -5 on the left. Get -9 over to the other side by adding 9, not 19, by adding 9. You add it to the right, add it to the left. -5 plus 9, opposite sign, subtract them. 9 minus 5 is 4. Keep the sign of the larger number 9. It's positive, so it's going to stay as positive 4. X is equal to 4. The rest of them in a minute. Okay, number 10 says 8d plus d plus 5d minus 6 is equal to 6d. Remember, before you try to move anything across the equal sign, you need to combine everything that's on one side, or you need to simplify it. So in this case, we can combine like terms. 8d plus d plus 5d. 8d plus d is 9d. 9d plus 5d is 14d. You still have -6 there. You can't put those two together and get 8d. Because -6 doesn't go with the 14d. So right now we're finished with combining that side, equals 6d. Now it's time to move stuff across the equal sign. Now normally we would move that smaller 6d over to that larger 14d. But since -6 is the only constant term, let's just move the 14d over to where we don't have to move the -6 after. So it says positive 14d. That's the same thing as plus 14d. Undo that by subtracting 14d. If you do it from the left, do it from the right. 6d minus 14d. Opposite signs, subtract the absolute values. 14 minus 6 is going to be 8d. And then since 14 is a larger absolute value, it's going to keep that negative sign, that's 14. So negative 8D is equal to, that's gone now. You still have negative 6 over there. A few people in every class are forgetting that the sign in front is the one that goes with it. So you got to don't forget that there's a negative in front, that's 6. We don't have D by itself. In order to get D by itself, look just at the side where the D is and undo the fact that it says negative 8 times that by dividing by negative 8. Undo negative 8 times something by dividing it. If you do it there, do it here. A negative divided by a negative is a positive, and the number 2 goes into both of these. It goes into 6 3 times, and it goes into 8 4 times. So D is equal to 3 over 4. Number 11 says negative 6 equals x over 8 plus 4. Undo your order of operations by getting rid of plus first. Remember, you work it backwards. So subtract 4. If you subtract 4 from the right, subtract 4 from the left. You need to do this the way you can see the left from the right. That's fine. Negative 6 minus 4. Add them up. 6 and 4 is 10. Keep the common sign, negative. You get negative 10 is equal to x over 8. This part is gone right now. We just canceled it. Now, since addition and subtraction is done, cancel out multiplication and division by canceling out divide by 8 by multiplying by 8. If you multiply that side by 8, it's going to cancel it out. You multiply, do the same operation on the other side. Positive 8 times negative 10 is going to be negative 80 is equal to x. Number 12 says 2/5 x minus 9 is equal to 8. Again, get rid of minus 9 by adding 9 to both sides. If you add 9 to the left, add it to the right. So what you have now is 2/5 times x is equal to, that's gone, 8 plus 9 is 17. Now 2/5 times x, typically you would undo multiplication by dividing, and we would divide by what's not x, and what's not x in this case is 2/5. But remember, dividing by fraction is the same thing as multiplying by its reciprocal. So to save yourself a step, just multiply by the reciprocal, which is a fancy word that means flip it. So if you multiply the left by 5 over 2, you multiply the right by 5 over 2. Now this isn't going to be nice and neat for us, you can clearly see, but it's going to give us something that we can work with. Okay, it's going to cancel this out right here, and it's going to leave us with x. When you multiply straight across, 17 times 5, we know 7 times 5 is 35. 5 times 1 is 5 plus 3 is 85. And 1 times 2 is 2. So 85 over 2 is, even though it looks really ugly, a simplified answer. 9 is equal to negative d plus 6. Move your, or get rid of your positive or plus 6 by subtracting it. Do it here. 9 minus 6 is 3 equals negative d. Remember, that's the same thing as negative 1 times d. Undo that by dividing by negative 1. Do it here. A positive divided by negative is a negative. 3 divided by 1 is 3 is equal to d now. D is equal to negative 3. 14 says 10 plus z over 3, 10 plus z over negative 3 is equal to 2. Remember, you can't cancel out that 10 plus z first before you cancel out that divide by negative 3 by multiplying. If you do it there, do it here. Negative 3 times 2 is negative 6 is equal to 10 plus z. Remember, and the reason we did that, the reason we skipped that 10 plus z part is because of that fraction bar act like a grouping symbol. So that says positive 10 or plus 10, subtract 10. If you do it to the right, do it to the left. Again, same signs, negative 6 and negative 10. Add them up. 6 and 10 is 16. Keep that common sign, negative. This goes away, and z is equal to negative 16. For this one, you have to do some combining. Before you try to undo anything, there's something we can put together. We can put 59 and we can put 7 together. 59 plus 7 is going to be 68. All I did was I went 59 plus 7, excuse me, is 56. Plus 9c. Now we can't put those two together and get 65c because one has a c term, the other one doesn't. So it's equal to 129. Move 56 over by subtracting it since it says positive or plus 56. If you do it from that side, subtract 56 from this side. 9 minus 6 is 3. 12 minus 5 is 7. So we have 9 times c Okay, I knew that looked funny. We got it corrected though. It's not 59 plus 7 is not 56. It is 66. So now we got it fixed. 66. This one's going to be minus 66. So this one's going to be minus 66. That looks a whole lot better. So when we subtract 9 minus 6, we still get 3. 12 minus 6 is going to be 6. Now this looks a whole lot better. We can get rid of 9 times C by dividing by 9. If you do it to the left, do it to the right. C is equal to 63 divided by 9 is the number 7. You got to distribute for number 16. 6 times y is 6y. 6 times negative 4, positive times a negative is a negative 24, is equal to negative 6. Move your minus 24 over by adding 24 to both sides. Negative 6 plus 24, you subtract them. 24 minus 6 is going to be 18. And since 24 is the larger absolute value and it's positive, it stays positive. 6y is equal to 18 since that cancels. Divide by 6 on both sides, and y is equal to 3. Number 17, we're going to have 3 steps involved. Undo your addition and your subtraction first. You're still following the same model. If you subtract 11 on the left, subtract 11 on the right. 23 minus 11 is going to be 12. Is equal to, we still have 4 times P, and we still have divided by 9, by 5. Cancel out divide by 5 next by multiplying by 5. It'll cancel out and leave you with 4P equals 12 times 5 is the number 60. And then finally cancel out 4 times something by dividing by 4. If you do it here, do it here. It'll cancel out. P is equal to 60 divided by 4, which is 15. '18 says find the value of y. Okay, so all you're doing is solving for y. Not anything special. Simplify negative 6y and positive 4y. Subtract them. Negative 6 plus 4 is going to be negative 2y plus 14 equals 32. So now the left side simplified. You can't put negative 2y and 14 together. So move over plus 14 by subtracting it. If you subtract it from the left, subtract it from the right. Negative 2y is equal to 32 minus 14. We're going to have to borrow that and leave it with 2. 12 minus 4 is 8, and 2 minus 1 is 1. So negative 2y is equal to 18. Divide by negative 2 to cancel that out. A positive divided by negative is going to be a negative. 18 divided by 2 is 9. Number 19 says a camera manufacturer spends $1,850 a day for overhead expenses plus $9 per camera for labor and materials. They sell for $14 each. How many cameras must he sell to equal his costs? Well, his costs are going to go on this side, and how much he makes is going to go on this side. And I know that's just, those are just descriptions of what's going on. So it costs him $1,850 plus $9 per camera. So 9 times X is equal to how much money he makes. He makes $14 per camera, or times the amount of cameras. So now just move your smaller X over to your larger one. You just have a simple equation. Subtract 9X. If you do it to the left, do it to the right. 14x minus 9x is 5x, is equal to 1,850, and this is gone now. Get rid of 5 times something by dividing by 5 on both sides. 5 goes into 18 3 times, and there's 3 left over. 5 goes into 35 7 times, and it goes into 0 0 times. So 370 is equal to X. So what this is saying is he has to make 370 cameras, or sell 370 per day in order to equal his costs. It says if he increases his production by 50 cameras per day, what would their daily profit be? Okay. So, well, it costs him $14 to make the cameras. He sells them, and it costs him $9. So 14x, or 14, we could just do 14 minus 9 says that he makes $5 per camera. So $5 times X. So $5 times X, or 5 times, if it says 50 cameras, you multiply 5 times 50, and he's going to make $250 more per day. That's the second part of the Question. He makes $250 for every 50 cameras he sells. A copy center offers its customers two different pricing plans for black and white copies. 8.5 by 11-inch pages. Those numbers are irrelevant, just like they were last week. Customers either pay 8 cents a page or can buy a $7.50 discount card that lowers the cost to 5 cents per page. So no discount is first, and then with the discount will be second. Okay. So with the discount, it costs you $7.50 plus 5 cents times the amount of copies. When will that be equal to no discount, which is simply 8 cents times the amount of copies? So even though we have decimals and we have long numbers, this is a simple equation. Subtract 5 cents x from both sides. And you have 3 cents times x is equal to $7.50. Divide this one to get x by itself by 0.03. Do the same thing over on this side. 3 goes into 75, we know 25 times, and 3 goes into 0 times. So you have to move your decimal over in order to accommodate that. So you have to make 250 copies in order for them to be correct, or in order for you to justify the discount card. 250 copies. Solving these two simple equations. Undo minus 4 by adding 4 to both sides. X is equal to negative 5. It says plus a negative, y minus 6 equals negative 10. Undo minus 6 by adding it to both sides. Y equals a negative plus a positive, opposite sign, subtract them. 10 minus 6 is going to be 4. 10 is larger, it's negative. Y is negative 4. And then simplify the last two. Negative 7 to the third power means 7 times 7 times 7, not negative 7 times negative 7 times negative 7, not the sign. This gives you 49 times 7. We know 7 times 9 is 63. 7 times 4 is 28, plus 6 is going to be 34. So 343, and then this little negative comes down in front of it to give you negative 343. And then the last one says negative 17z minus 30z. The same sign, add them up. 30 plus 17 is 47z. And they're both negative, so keep it negative. Don't get confused with multiplying a negative times a negative. We're simply adding and subtracting that one.